Once again, good morning everyone. So this morning we are going to discuss about the properties of fire. Okay, so I'm going to present first the objectives for the study. So there are three objectives. One, value the importance of the properties of fire. Number two, articulate the common phases of burning or the stages of fire. And number three is conceptualize fire suppression, control, and extinguishment and extinguishing agent. So these are the objectives. So let us start with the properties of fire. So the properties of fire are the physical property and the chemical properties. So what is this physical property all about? So the physical property, which is any property that is measurable or it can be measured. Measurable where value describes a state of physical system. So in short, this can be measured. This is measurable. How about the chemical property? So the chemical property is any of a material's properties that becomes evident during or after a chemical reaction. So what does it mean? That the chemical property is a properties, materials property that becomes evident or which is visible during or after the chemical reaction. So there are physical properties. Since this is physical properties which are measurable, so there are physical properties, and one of these is specific gravity. So what is this specific gravity? So the ratio of the weight of a solid or substance to the weight of an equal volume of water. So since physical properties are measurable, so the specific gravity, this is the ratio of the weight of the solid which are involved, or the substance of the weight of an equal volume of water. So aside from the specific gravity, the vapor density. So what is this vapor density? So this refers to the weight of a volume of a pure gas compared to the weight of the volume of dry air at the same temperature and pressure. So this vapor density, this refers to the weight of a volume of pure gas. This is being compared with the weight also of the volume of dry air at the same temperature and pressure. Then aside from the vapor density, the vapor pressure. So what is this vapor pressure? So this refers to the force exerted by the molecules on the surface of the liquid at equilibrium. So this vapor pressure, the force exerted by the molecules, the force which is exerted, which is used on the surface of the liquid at equilibrium. Then how about the temperature? So next is the temperature. Refers to a thermal degree of the agitation of molecules of a given substance, the measure of the molecular activity within the substance. So this temperature, referring this to the measurement of heat, the thermal degree of agitation, the measuring of the heat of the molecules in a given substance, as well as the activity of the molecule which is being measured within a substance. Next is the boiling point. So, what is this boiling point? So, the boiling point is the constant temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. So, what does it mean? That this is a constant temperature. The boiling point, the constant temperature or the heat at which the vapor pressure or the pressure of the vapor of the liquid is equal to the atmospheric pressure. Next is the ignition temperature or kindling temperature. So what is this all about? So this refers to the minimum temperature to which the substance in the air must be heated in order to initiate or cause self-contained combustion without the addition of heat from the outside sources. What does it mean? So this refers to the minimum or the minimum temperature, the regular temperature or the heat in which the substance in the air must be heated. For what purpose? In order to initiate or start the cause of self-contained combustion without the addition of the heat from the outside sources. Next is the fire point. So what is this fire point? So this refers to the temperature at which the material will give off ample vapors to keep burning. So there is usually about 5 to 10 degrees difference between the flash point and the fire point of most materials, since these two are just a few degrees apart. So talking about fire point, meaning this is the time that the fire is going to start because of the exact or the amount of temperature as well as the oxygen. That's why the fire point, the temperature at which the material will give off ample or enough vapors to keep burning. So this fire point means the actual firing, the actual fire. Then there is the flash point. So what is this flash point? So this is the temperature at which the material is not hot enough to keep burning, but still give off enough vapor to cause a flame to flash across the surface. So the term flash point is used to express the condition of fuel vaporizing fast enough to keep burning. So this flash point, so this is temperature which is about to start the fire, but it cannot start because this material is not hot enough to keep burning. Unlike in the fire point, because in the fire point, the exact temperature as well as the so-called that will give off vapors to keep burning. But the flash point is not hot enough, or in short, this flash point is about to start a fire, but cannot start the fire because it is not hot enough to keep burning. So these are the physical properties. Let us now move on the chemical properties. It is said that the chemical property is any of the material properties that becomes evident or visible during or after chemical reaction. So the chemical properties involves endothermic reaction, exothermic reaction, oxidation, and the combustion or flame. So one of these chemical properties I mentioned is the endothermic reaction. So what is this endothermic reaction? So these endothermic reactions are changes. So these are changes whereby the energy, or referring this to the heat, is absorbed. So is absorbed or is added before the reaction takes place. Before the reaction will take place, or before the reaction will take effect, the heat is, or the energy is absorbed or is added. So before reaction takes place, the heat or the energy or the heat which is being absorbed or which is added before reaction takes place. Next to this is exothermic reaction. So this exothermic reaction, the reactions or changes that release or give off heat energy, that they produce substances with less energy than the reactants. So this exothermic reaction, this is opposite to endothermic. Because in the endothermic reactions, the heat is absorbed, whereas in exothermic, the heat is released. So reactions or changes that release or give off energy, thus they produce substances with less energy than the reactants. Next is the oxidation. So what is this oxidation? So the oxidation is a chemical change or changes of the chemical. So the chemical change in which combustible material, referring this to the fuel, and oxidizing agent react. So this is the reaction of the combustible material, the reaction of the oxidizing agent. The chemical change in which combustible material or fuel and oxidizing agent react. Then the combustion or flame. So what is this all about? So the combustion of flame, this refers to the manifestation of fire when the fire in its gas phase combustion, a matter that is produced by fire. So the combustion which is produced by fire. Manifestation of fire, the actual fire, when the fire in its gas phase combustion and a matter is produced by fire. Next to that properties or chemical properties of fire, the phases of burning, or the stages of fire. So there are three stages, or the three phases of burning, or the stages of fire. So what are they? So one is incipient or beginning phase. Number two is free burning phase. Number three is smoldering phase. So these are the phases of burning or the stages of fire. One of these is incipient phase. So what is this incipient phase? Why do we call this incipient? So the incipient or beginning phase is this initial stage of the fire. In short, this is the start of the fire. So the initial stage of the fire. So there are characteristics. When the fire is started, there are characteristics. So what are those characteristics when fire is starting? Because this initial phase or the beginning phase is the initial stage of the fire, so there are characteristics. So what are those characteristics? So the characteristics, there are characteristics. So what are those characteristics? So the characteristics are 1, normal room temperature, 2, oxygen plentiful, 3, thermal updraft rise accumulates at higher point, then flame temperature of 100,000 degrees Fahrenheit, and the producing pyrolysis products. So one of the characteristics is normal room temperature. The room temperature is normal. That is why the fire is going to start because of normal room temperature, means that the heat is normal. Oxygen is plentiful, meaning there are enough oxygen. Thermal updraft accumulates at higher point. So because of enough oxygen, the temperature, the thermal updraft rise or will rise, accumulate at higher point. So it means that it tends to rise. The thermal updraft tends to rise, accumulates at higher point. Then flame temperature of 1,000 degrees Fahrenheit, meaning the temperature, the measure of heat, the flame temperature is 1,000 degrees Fahrenheit. Then it produces pyrolysis products. So because this is the start of the fire, that produces pyrolysis products. So the product of producing pyrolysis. So these are characteristics of the incipient or beginning phase or the initial stage of the fire. Next is the free burning phase. So the second stage of the second stage of the fire is the free burning phase. So after the fire is started, the next is the free burning phase. So what is this free burning phase? Why this free burning phase differs from incipient or beginning phase? So this free burning phase, the second phase of burning, in which materials or structures are burning in the presence of adequate oxygen. So this free burning phase, which is the second phase of burning, in which the materials or structures which are involved in the fire are burning in the presence of adequate or enough oxygen. So in the pre-burning phase, there are characteristics. They say that the structures are burning in the presence of adequate oxygen, meaning the oxygens are enough. So what are those characteristics? So there are characteristics. 1, fire has involved more fuel. 2, oxygen is depleted. 3, accumulates at upper area. Then 4, temperature exceeds 1,000 degrees Fahrenheit or 705 degrees centigrade. Then area fully involved. So one of these is fire has involved more fuel. So one of the characteristics of the free burning phase is fire has more fuel. So fire has involved more fuel. So many or more fuel are involved in the fire. Then oxygen is depleted. So enough oxygen. Then heat accumulates at upper area. So it started upward. Then temperature exceeds 1,300 degrees Fahrenheit or 700 degrees centigrade. Or the area is fully involved. So meaning the area of the fire is fully involved. Next is the smoldering phase. Okay. So the third phase of fire or stages of fire is the so-called smoldering phase. So this final phase of burning wherein flame ceases, but then smoke and heat completely fills the confined room. So what does it mean? So in the smoldering phase, the flame has stopped. So the final phase of burning wherein flame ceases means the stop, but dense smoke and heat completely fills the confined room. So the flame has stopped, but the dense smoke and heat that completely filled the confined room. So if the room is on fire or property is on fire and it is smoldering, meaning the flame has stopped. What is visible there is the dense smoke and heat completely fills the confined room. So in the smoldering phase, there are characteristics. So what are those characteristics of this smoldering phase? So the characteristics are flames may die and leave only glowing embers or superheated fuel under pressure with little oxygen. So meaning flames may die. So it means that the flame ceases or has stopped and leave only glowing. That's glowing embers or superheated fuel under pressure with little oxygen. Okay, so that's the first characteristics. The flame may die and leave only glowing embers or superheated fuel under pressure with little oxygen. Next is intense heat will vaporize lighter fuel components such as hydrogen and methane, increasing the hazard. So intense heat or the increase of the heat will vaporize lighter fuel components such as hydrogen and methane, increasing the hazard. Another characteristics of the smoldering phase is temperature throughout the building is very high. So it's very true that the temperature or the heat of the building is very high and normal breathing is not possible. So if you are near to this, the area where the fire is smoldering, in a smoldering stage, so it is normal breathing is not possible because of because of the temperature which is very high. The temperature of the building is very high and normal breathing is not possible. Then the oxygen deficiency because backdraft. So the oxygen deficiency, meaning the oxygen is not enough, is lacking, that cause backdraft. Okay. So those are the stages of fire. So since the smoldering phase that cause backdraft, so what is this backdraft? Okay. So the firefighters operating at fires in buildings must use precautionary measures where opening a building or to gain entry by providing ventilation either by horizontal or cross ventilation. So by opening of doors or windows or vertical ventilation, so opening a hole at the highest portion of the affected part of the building. So this backdraft, so it means that for example, the room is fully consumed by the so-called fire, and that causes backdraft. So in opening of the room or building, for the firefighters to penetrate, so they must use precautionary measures when entering, because when they are going to open the door without protecting or protective covering, so it's very hot. This is called backdraft. When you open the area which is confined with fire, enclosed room which is confined with the fire, when you open the door or window, so that causes backdraft, and this is very dangerous to the firefighters when entering the building without proper protective equipment. So in producing holes, they are going to ventilate the area by either horizontal or vertical ventilation. So as the fire grows in a more confined area, so as the fire grows or increase in the fire area, large volume of hot unburned fire gases can collect in unventilated spaces. So when this is open, those very hot objects inside will come out. So, as the fire grows in confined area, a large volume of hot unburned fire gases can collect in unventilated spaces. And these gases may be at or above their ignition temperature but have insufficient oxygen available to actually ignite. So, any action taken during firefighting operations that allows air to mix with these hot gases can result in an explosive ignition, which is called backdraft. When you open the door or window, this can result on explosive ignition. And this explosive ignition, which is called backdraft, when you are going to open the door and you are going to open, then penetrate immediately, then the backdraft you will be encountering the very hot object, or what we call that backdraft. So the danger for backdraft can be minimized. So this can be minimized with proper application of vertical ventilation. So vertical ventilation meaning you are going to open the rooftop, in order that the so-called very hot materials inside will come out at the top portion. So the danger for backdraft can be minimized with proper application of vertical ventilation, causing the unburned gases rise and release through the opening before an entry is made. So you are going to open first before entering. Because when you open it, the moment you open the door, then immediately you enter, so you will encounter the so-called backdraft, the very hot objects that will be encountering if you are going to enter immediately upon opening. There are conditions that indicates danger for backdraft. So what are those conditions? Okay, that indicates the danger for backdraft, because this is very risky on the part of the firefighters. So the conditions that indicate the danger for backdraft, such as pressurized smoke exiting small opening. So this smoke, the pressurized smoke, there is a pressure of the smoke that exit or will exit from small openings. That's why if the building or room is closed, when you are going to open the smoke, the pressurized smoke will exit, will come out. So black smoke becoming dense gray yellow. So the black smoke that will come out when opening becoming dense gray yellow. Then confinement and excessive heat. So in confinement, when this is confined, the heat is increasing. Confinement and excessive heat. Then little or no visible flame. So little flame or no visible flame. So if the building is smoldering, so it is impossible for you to see flame. So little or no visible flame. Then smoking or smoke leaving the building in puff or at intervals. So the smoke that leaves the building, especially exiting to a small hole, small openings. The smoke leaving the building in puff or at intervals. So it means in puff or not continuous or in the form of an interval. Then the smoke-stained window. So the window, if you are going to look at the window, that contains stained on the smoke. Smoke-stained window. Next is the flashover. So what is this flashover? So the flashover occurs when a room or other area is heated enough that flames sweep over the entire surface. So this flashover happen when a room or a building or other area which is heated, which is on fire, which is heated enough that flames sweep over the entire surface. Firefighters, very interested the personnel of the fire department, firefighters originally believed that combustible gases released during the early stages of the fire cause flashover by collecting at the ceiling and mixing with air until they burst into flame. Then the combustible material is grouped into one of four classifications. So these classes of fuel help to simplify firefighting methods and techniques. So there are four classifications. So there are classification of fire. So what are those classification? So the classification of fire based on cost and based on burning fuel. So classification of fire based on cost. These are classified into natural, accidental, intentional. So based on cost, natural fire. Talking about natural fire, the fire is caused by nature. Like for example, forest fire, or because of the intense heat in the forest, natural fire, or the fire caused by lightning. So natural fire. The accidental fire. So what is this accidental fire? So the fire is initiating because of an accident. Like for example, faulty electrical wirings. Wirings are there is what we call the wirings are defective. So there is what we call this defective or faulty electrical wirings that cause fire. That's accidental. Intentional fire. So what is this intentional fire? Talk about intentional fire. So it means that somebody is responsible for setting the fire. And those persons responsible for setting the fire can be charged for the crime of arson. So, arson is a crime. So intentional in the sense that this was caused by a human being. It is not accidental. It is intentional. So intentional in the sense that it is caused by human being, and those person who caused the setting of the fire of the property of another person is liable for the crime of arson. Based on burning fuel. Okay, so there are four classes of fire. Okay, actually there are four classes. But one is added to make it five. Okay, so there are four classes of fire: class A, class B, class C, class D. And last, in addition to that is class K. So let us start with class A, the classes of fire. So what is this class A all about? So the class A fire, materials involving vegetable fibers. So in class A fires, that involves materials, the materials such as vegetable fibers, wood, paper, straw, grain and grass, combustible materials such as coal and coke. Nearly all trash fires are considered as class A fires. So a class A fire that involves vegetable fibers, wood, paper, straw. These are class A fire. Okay. So if this is on fire, this is classified as class A fire. So if the wood, papers are on fire, so these are classified as, or this is going to be classified as class A fire. How about the class B fire? The materials including petroleum products such as gasoline, fuel oils, lubricating oils, and greases, animal fats such as butter, lard, and tallow, and vegetable extracts such as alcohol, linseed oil, and turpentine, vegetable compounds such as shortenings and oleomargarines, natural gases and compressed gases such as butane, propane, hydrogen, and acetylene. So, if the materials involved are petroleum products, so these are classified as class B fire. So the class B in the sense that because the materials involved in the fire are petroleum products, not ordinary combustible materials. Because if this is ordinary, class A. But if the products involved in the fire are petroleum products, these are classified as class B fire. Next, class C fire. So what is this class C fire? This type of fire involves electrical motors, electrical appliances, and apparatus. Actually, class C fire is composed usually of class A and class B materials or combination of both. Use of water is usually dangerous because of the risk of electrical shock. So what does it mean? So we talk about this class C fires that involves electrical motors. This involves electrical appliances. And apparatus. So, electricity is involved in this kind of fire. So, this type of fire involves electrical motors, electrical appliances, and apparatus. So, actually, Class C fire is composed of usually of Class A and Class B materials or combination of the both. Then, using water is very dangerous on the part of the firefighters, especially if they are spraying this to the affected part continuously. This will cause the electrical shock. So, when this is in this kind of situation, when electrical appliances are on fire, so the use of water is dangerous. But you can use the water, the firefighter can use the water in spray form, not continuous. Because this is that cause electrical shock when it is continuous. Okay. The other class is Class D fire. So these are materials involving combustible metals, alloys, or metal compounds either in a solid or semi-solid state. So this Class D fires that involves metals. Metals are on fire. So these are materials involving combustible metals, alloys, or metal compounds either in a solid, semi-solid, or liquid state. So they may further reduce in sheathings, grindings, granules, or dust. Some liquid metals are kept in a liquid state under pressure. Usually, these liquid metals are extremely dangerous. Okay, so the Class D fire that involves combustible metals. Metals are involved in the fire. So metals are involved in the fire. So some of the unusual metals which are involved in the fire such as magnesium. So these are unusual metal. Titanium, sodium, potassium, and uranium, as well as pyrophoric or organometallic reagents such as alkylithium, lignites, and zinc. So this type of materials burn at high temperature and will react violently with water, air, and other chemicals. So when combustible metals are on fire, that will react in water. That is why water is not you are not advised, or the firefighters are not advised to use water when extinguishing or suppressing the fire, because the water will react to the so-called combustible metals. So this they are going to use extinguishers in order to stop the fire. Okay. So this type of materials burn at high temperature. This is burning in high temperature and will react violently with water. When water is used, will react. This will react. And there is a specific extinguishing agents that is going to be used. It is the dry powder chemicals. Dry powder chemicals is going to be used in stopping this kind of fire. The combustible metal. Then Class K. So these are materials involved in kitchen fires. So this Class K, this is in addition to the classes of fire. The Class K, these are materials involved in the kitchen fires, and this classification was added to the NFPE portable extinguisher standard in 1998. So this is in addition to the classes of fire. Actually, there are 4 classes of fire. But this Class K, this refers to the kitchen fires, kitchen fires which are involved in the fire. But this is in addition to the what we call this classes of fire, which is added to the NFPE portable extinguisher standard in 1998. Next is spontaneous heating. So what is this spontaneous heating? Spontaneous heating or spontaneous ignition starts as a result of a chemical reaction within the material, a reaction independent of any outside source of heat. So what does it mean? That spontaneous heating or ignition starts as a result of chemical reaction. When the chemical is reacting to this to the particular fire. So this is called spontaneous or spontaneous heating or spontaneous ignition. This starts as a result of chemical reaction. This will start when chemical is reacting. So within the material, a reaction independent of any outside source of heat. Spontaneous heating begins or starts a cycle of oxidation. So this started with oxidation that builds up heat very slowly in the first stage. So this started with when the heat starts slowly. So the condition that builds up temperature high enough to cause ignition is called spontaneous heating. Okay? So at this point, it becomes also a spontaneous ignition. So it started with a very slow oxidation. So the spontaneous heating starts with a cycle of oxidation that builds up heat very slowly. Started with heat very slowly. Then it increases. So the condition that builds up temperature high enough from low temperature to high temperature, temperature high enough to cause ignition, which is called spontaneous heating. And at this point, it becomes spontaneous ignition. So in most materials, this process develops slowly and does not reach its ignition point for days or even weeks. Consequently, fires may break out today that were actually started days before. Usually, there is enough air to allow oxidation, but not enough air to carry the heat from the area. Then some of the common materials that may be spontaneously heated and ignited are animal oils, mixed fish oils, linseed oils, coal, coke, charcoal, sodas, ghee, green, and cotton. So this is spontaneous heating or spontaneous ignition that starts as a result of chemical reaction, within the material. What is propagation of fire? So what is this all about? So the propagation of fire simply means the spread of the fire. So if the fire is spreading, the fire is increasing. So propagation of fire simply means the spread of the fire. As a substance burns, fire propagation will be increased by the transmission of heat by nearby materials. So the spread of the fire. That substance burns, fire propagation or the increasing or the spreading of the fire may increase by the transmission of heat. The transmission of heat by nearby materials. So this condition causes additional vapors to be released, thereby spreading the fire. So that's propagation of fire, means the spread of the fire. So the substance burns, which are burning. Fire propagation will be increased. How? By transmission of heat. By the transmission of heat to the nearby materials. And that condition causes additional vapors to be released, thereby spreading the fire. There are types of heat transmission. These are conduction, radiation, convection, then flame contact. So one of these is the conduction. So what is this conduction? So the conduction is the transmission of heat through an object. So this is the transmission of heat through an object or medium or conductor such as pipe, metal, hot air duct, wire, or even wall. So this conduction, the transmission of heat from an object, such as the pipe. When the opposite side or the opposite portion of the pipe is on fire, that will affect because that heat will conduct, or that is a conductor. So it is transmission of heat through an object or conductor such as pipe, metal, or hot air duct, wire, or even wall. So if portion of the pipe is on fire, then the rest of the part of the pipe will also be heated. That is conduction. Next is radiation. It's the transmission through the discharge and spread of heat from a heated or burning source. So this radiation takes place through the air or through a space that cause another flammable objects to ignite. So what does it mean? So the radiation is transmission through the discharge and spread of the heat. When the heat is spreading from a heated or burning source, and this radiation takes place through the air. So, that will transfer. For example, if one building is on fire, but because of the strong wind, the other building is also affected by fire, and that is called radiation. So the transmission of the transmission through the discharge and spread of the heat from a heated or burning source. This radiation takes place through the air or through space that cause another flammable object to ignite. So that is radiation. So it means the spreading of the fire because of the strong wind. The other building which is not on fire, but because of the strong wind, the fire is spreading, and the other building is also affected by fire, and that is called radiation. Then convection is the transmission of heat by moving currents or of liquids or gas. When these gases or liquids are heated, they start to move within themselves, and by their free motion, circulation starts. Okay, so this convection, so it means that when the fire is started at the ground floor, then the second floor or the first floor is also affected. That is convection, the transmission of heat by moving currents or liquids or gas. When these gases or liquids are heated, they start to move within themselves, and by their free motion, circulation starts. And it can be compared also when using a burner, using cooking materials, putting water there, then it is heated, then the circulation that starts among themselves. Then the fourth is the flame contact. So what is this flame contact? So the flame contact, heat may be conducted from one body to another by direct flame contact. Fire spreads along or through burning material by flame contact. When a material is heated to the point where flammable vapors are released, the vapors may be ignited. Any flammable material may be heated to its ignition temperature by direct contact with the flame or burning vapors. So the flame is in contact with another flammable materials. So that is why heat may be conducted by one body to another. So flame contact. So when the building is on fire, and the other building is not on fire but made of light materials, because of the strong wind, the flame is contacting with another material which is made of light material, so that will cause fire. So flame contact. Intensity of fire. So what is this intensity of fire? So intensity of fire means simply how hot the fire is burning. Some types of fuels naturally burn hotter, more intensely than others. For example, a gasoline fire burns hotter than a wood fire, while acetylene flame is hotter than a gasoline flame. So the intensity of fire is how hot the fire is burning. That is why if you are going to compare gasoline fire than wood fire, gasoline fire burns hotter compared to a wood fire. If you are going to compare acetylene flame with gasoline flame, acetylene is hotter than a gasoline flame. Okay, that's the intensity of fire. The factors to determine the intensity of fire are the types of fuel. Is it solid, liquid, gas? Percentage of oxygen present. So, is it 100%? Is it 50%? Is it 75%? Okay. So, percentage of oxygen present. Magnitude of fire. So, what is this magnitude of fire? So, the magnitude of fire means the size of the fire, and it's governed by the surface area of fuel exposed to the air. So, the magnitude of fire means the size of the fire. And is governed by the surface of fuel exposed to the air. The magnitude of fire is not always determined by the amount of fuel involved, but more often by the amount of fuel exposed to the air. So that is magnitude of fire. The size of the fire. The coverage of the fire. Then the flash point. So what is flash point? The flash point means the temperature at which the material is not hot enough to keep burning but still give off enough vapors to cause a flame to flash across the surface. So in short, this flash point, this is about to start a fire, but it cannot stand alone. This is about to start a fire. It is different from fire point because the temperature of this is not hot enough to keep burning, but still give off enough vapor to cause a flame to flash or about to start. That is flash point. Then the fire point is the temperature at which the material will give off ample vapors to keep burning. So there is usually 5 to 10 degrees difference between the flash point and fire point of most materials. So since the two are just a few degrees apart, the term flash point is used to express the condition of fuel vaporizing fast enough to keep burning. So this fire point, so it means the fire, the start of the fire. The temperature at which the material will give off ample vapors or enough vapors to keep burning. So it means that this fire point is the fire itself. The flash point is about to start the fire because the temperature is not hot enough to keep burning, but the fire point will the material that give ample vapors to keep burning. It means that the fire point is the actual fire. Ignition temperature. So what is this ignition temperature? So the ignition temperature is the degree of heat necessary to ignite flammable vapors. So this temperature can come from an external source such as match, spark, and friction. So the ignition temperature. So the temperature that come from external source. So what are those external sources of temperature such as the match, safety match, sparks from welding machine. While conducting or wielding a metal, or friction, or the striking of one object against another, or if the fuel itself is raised to this temperature, or auto-ignition or self-ignition will occur. Next is, let us move on the fire suppression, control, and extinguishment and extinguishing agents. So let us going to know what is fire suppression, what is fire control, what is fire extinguishment, and the extinguishing agents. So the proper selection of an agent or method of control or extinguishment is the most important factor in determining the degree of a success of a firefighting operation. So the proper selection or the method that they are going to use in order to succeed in fighting the fire. So, what is fire suppression? So, fire suppression means slowing down the rate of burning. So, what does it mean? If you're going to suppress the fire, you are going to slow down the fire, but not to extinguish the fire. If the fire cannot be extinguished, you are going to slow down the fire or reduce the temperature by spraying it with water to reduce the temperature. If not to extinguish the fire. That is fire suppression, slowing down the rate of burning. Whereas control, so fire control means keeping the fire from spreading or holding the fire to one area. So what does it mean? So the fire control means keeping the fire from spreading. How are you going to keep the fire from spreading? So like for example, if one building is on fire and the neighboring building is not on fire, so you are going to control the fire by spraying the neighboring building with water in order that the fire cannot spread to another building. That is control. Fire control means keeping the fire from spreading or holding the fire to one area so that the fire cannot spread to another building. That is why when the building is on fire, which consumed 90% consumed by fire, so it is impossible for the firefighters to stop the fire or extinguish the fire because the building is almost 100% consumed by fire. So what they are going to do is to control the fire, to confine the fire. The neighboring building will be sprayed by the fire hoses so that the neighboring building will not be affected by the fire. That is control, means keeping the fire from spreading or holding the fire to one area. Extinguishment is putting the fire completely out. Talking about extinguishment, means the fire is completely out. So if the fire cannot be extinguished because the fire is increasing, the fire can be suppressed, slow down the rate of burning. But if you can extinguish the fire, that's better. So fire suppression means slowing the rate of burning, whereas control means keeping the fire from spreading, holding the fire to one area. Then extinguishment is putting the fire completely out. So in extinguishment, so it means the fire is totally out. Okay. There are three ways of suppressing, controlling, and extinguishing a fire. So there are three ways. What are they? Cooling, smothering, separation. So there are three ways of suppressing, controlling, and extinguishing a fire: by cooling, by smothering, by separation. One of these is cooling. So what is this? The cooling process uses an extinguishing agent. What extinguishing agents are you going to use in order to cool the fire? So the cooling process uses an extinguishing agent whose primary characteristics is heat absorption, meaning the heat is being absorbed. Water is the best general cooling agent for firefighting purposes. So in cooling, water is the best general cooling agent for firefighting purposes, because the primary purpose of this is heat absorption. That's why water is the best general cooling agent for firefighting purposes. And this water can be used on Class A fires. So the water absorbs the heat generated at the surface of the burning material, thus reducing the temperature of the material below its flash point. So using water, spraying the fire with water, used to cool the fire, used to reduce the temperature below its flash point. Water can also be used on Class B fires. So aside from using this on Class A fires, this can also be used on Class B fires, which include flammable petroleum products. So this also used in Class B fires. The fire involves petroleum products. As with a Class A fire, the water absorbs much of heat, reducing the vaporization rate of the liquid fuel. This is the most noticeable in fire involving lubricating oil, whose flash point at 45 degrees Fahrenheit. Water would cool gasoline below its flash point. The extinguishing ability of the water is broken into fine particles to accelerate heat absorption. So with regards to petroleum products, in order to extinguish the fire, so the extinguishing ability of the water is broken into fine particles, means in spray form, broken. The whole fire hose is going to be adjusted to make the water release fine particles. Okay, so the extinguishing ability of the water is broken to fine particles to accelerate the absorption. So that's why cooling agent, water is the best general cooling agent. Next to that cooling is smothering. Excludes the oxygen from the fuel so that the gases or vapors of the fuel cannot ignite and continue the combustion. This is smothering that excludes the oxygen from the fuel. Like for example, you are burning coconut shell inside a drum. If you're going to cover that one, that's smothering. Exclude the oxygen from the fuel so that the gases or vapors of the fuel cannot ignite and continue the combustion. You cover the drum. Okay? Next is separation. So what is the separation? In smothering, you are excluding the oxygen by covering the container to exclude the oxygen. In separation, this is the removal of the fuel, as in the example of turning off the valve in a gas line prevents the fuel and oxygen from coming together. If fuel is not available, then heat, regardless of the temperature, cannot affect the fuel. Therefore, there is no fire. So, in separation, like for example, if you are cooking using the so-called LPG, if you are going to remove the fuel or turn off the valve, there is no fire. When you are going to cook your food using firewood, the fire is in progress. If you are going to remove the firewood, what will happen? It stops the fire. Okay? So, these three methods of extinguishment explain how fires are extinguished with the use of water, CO2, and foam. They do not entirely account for the results obtained by vaporizing liquids or dry chemicals. The vaporizing liquid could not possibly absorb enough heat to have the same effect as water, and dry chemicals do not exclude sufficient oxygen to smother a fire in the same manner as carbon dioxide. So, these are all about this separation. Okay, the fuel is removed. Next, extinguishing agents. So let us now move on the extinguishing agents. So there are extinguishing agents such as water, carbon dioxide, dry chemicals, dry powder, AFFF or aqueous film forming foam, halons or halogenated agent. So these are the extinguishing agents, the agents that used to extinguish the fire. And one of these, which is very common, is water. This is used by firefighters in fighting the fire. Okay? So, water, which is used on Class E fires. Water is the most effective in cooling the burning material below its ignition temperature. So, this is used in Class E fire. And this is commonly used by our firefighters. So, in order to reduce the heat or temperature, or as much as possible to extinguish the fire. This is one of the extinguishing agents, which is common at present, commonly used by our firefighters. Another agent is the so-called extinguishing agent is the carbon dioxide. So what is this carbon dioxide? So this is a CO2. So a number of its properties make CO2 a desirable extinguishing agent. That's why we have fire extinguishers used to extinguish the fire. So the fire extinguishers classified into carbon dioxide, dry chemicals. So these are some of the extinguishing agents which is used in extinguishing the fire. Another is dry chemicals. So the dry chemicals are also used. If you're going to look at the fire extinguishers, there are some of the fire extinguishers are dry chemicals. Common fire extinguishers, dry chemicals. And there are two basic types of these dry chemicals: the ordinary and regular dry chemicals, as well as the multi-purpose dry chemical. So what is this ordinary or dry chemical? So what is the use of this chemical? So this generally refer to those powders that are intended for use. This is the powder, because the content of these dry chemicals are the powders that are intended for use on Class B fire or Class C fire. So these dry chemicals, when a building or house is on fire, or because the fire started a small portion of that one. When the fire started, there is a what we call this fire extinguisher. So common common fire extinguisher is dry chemical. So you are going to use this fire extinguisher in order to extinguish the fire. So the dry chemicals can be classified into ordinary and regular. And these ordinary and regular dry chemicals, This is intended for use for Class B and Class C fires. How about the multi-purpose dry chemical? So another, aside from the ordinary or regular dry chemicals, the multi-purpose or dry chemical. Okay, this refers to powder listed for use on Class E, B, and C fires. So this can be used. The multi-purpose or many-purpose Class E, B, C fires. So this multi-purpose dry chemical. Then aside from the dry chemicals, the fire extinguisher also contains dry powder. So dry powders. So aside from dry chemicals, dry powders. So what is the use of this dry powder? So this general term, this is used in extinguishing combustible metal. So dry powder, if metal is involved in fire, combustible metal, so the right fire extinguisher that is going to be used is dry powder. So this dry powder generally extinguishes fires by excluding air from the combustible metal. So that's why if combustible metal is involved in the fire, dry powder chemicals is going to be used. Then the EFFF, or we call this aqueous film forming foam. Okay, so this is a form of a foam. So this is going to be used. So this extinguishing agent, its effectiveness depends on the proper application. So the effectiveness of this aqueous film forming foam depends on the proper application. And this is designed to be applied at a 6% mixture. So this is applied in 6% mixture. This is composed of water and EFFF or a foam. So if more waters are involved, example, 94 parts of water to 6 parts of EFFF. So more water which are also involved. Okay? So in EFF or aqueous film forming foam. So this is combined 94 parts of water to 6 parts of EFF concentrate used to extinguish the fire. Then the last is halons or halogenated agents. So these halogenated agents can be used to this agent work chemically to extinguish the fire. This is used to stop combustion by breaking the fire chain reaction. Okay, so this is used to break the fire, the fire chain reaction, and prevent further fire propagation and prevent the spreading of the fire. So this can be used in breaking the fire chain reaction, used to stop the process, stop combustion. Halogenated agents. This is an agent which work to extinguish the fire in order to break the fire chain reaction, just to prevent the spreading of the fire. So these are the extinguishing agents. Of the 6, water is commonly used by firefighters. The rest of this, in the form of fire extinguishers, are equipped, houses or buildings. Now, under the building code of the Philippines, if you are going to build a building, so that requires fire extinguishers. What is the purpose of that extinguishers? In order to extinguish a fire before the arrival of the firefighters, to minimize the increase of the fire using the fire extinguisher while the firefighters are going to respond to the fire scene. So that ends the topic for this morning. So this morning we discuss the about the properties of fire. So the properties of fire such as physical property and chemical properties. So the physical property, this refers to the property that is measurable. So this can be measured and described in the physical system. Then the physical chemical property, the materials that burns, materials property that becomes evident during or after the chemical reaction. Okay. Then there are stages of fire. Okay, stages or phases or the stages of fire, such as incipient phase, the free burning phase, and the smoldering phase. Okay, so in order to extinguish the fire, okay, so there are ways of extinguishing the fire by what we call this by smothering, okay, another way of extinguishing the fire, and also the extinguishing agents that used to extinguish the fire, water, the carbon dioxide, and others. So talking about fire suppression, it means the fire is slowing down. It's used to slow down the fire. Fire control means to confine the fire in one area to prevent the spread of the fire, and extinguishing the fire. Fire extinguishment means the putting the fire completely out. Okay, so that ends the topic for this morning.